the next kid, to the next generation. So we'll do that. So the first thing you do is put in all the genotypes. So plus is often used to mean the big letter, okay? It just means the normal, right? So it's just a, so instead of writing that the genotype is little cf, big cf, you write it's little cf plus, okay? Because there's a good allele. So we know the genotype of the parents here must be this. We know the genotype of these parents must be this too, right? Because otherwise they wouldn't have having a kid that had cystic fibrosis, right?
Yeah.
So we know those genotypes. We know this person's genotype. That's absolutely certain. And we know this person's genotype. Now we have to figure out the rest. All right. The probability that this child will receive the defective allele from his father is 1. Right? Does everyone agree with that?
Yes.
It's 1. So we know one number in our little equation. It's 1. Because that is the probability that the mutant allele will be passed on. 1 times something. So that we know with certainty. What is the probability that this person is a carrier? I say it's 2/3. Now, you say it's 3/4, right?
No.
Yes, that's right. So that's why it's, yeah. You see, you're thinking. Good. That's excellent. So what she's saying is, we know that this is not little cf, right? So it's either big CF, little CF, or big CF, right? And of those, it's twice as likely that it'll be the heterozygote or the carrier than the homozygote. Let's do it. In this mating here, right? Let's do that mating. Let's do that mating. I can't fool you back there. Whoever you are with the Emery shirt. That's good. All right, so we've got little CF, big CF, and little CF, big CF. All right, so you know that this person is not that. But then there's big CF, little CF, and big CF, and big CF, little CF. Right? So of the, there's no other color? Darn it. Of the non-affected individuals, which are these, right? Two-thirds are carriers, right?
Yes.
So there's a 2/3 probability that she's a carrier. Great. So now we have another number in here. 2/3 probability that she's a carrier. Now, probability that this child will receive the little CF from a mother, if she is a carrier, is what? 1/2, right?
Mm-hmm.
Because half the time she'll pass it on and half she won't. So now, you just multiply all that together, and you get 1/3. So you can go and tell these parents that there's a 1/3 probability, that their child will have cystic fibrosis. Do they want to take the chance? Okay? The other 2/3 of their children, what will be their genotype? So they'll be carriers, right? They'll be carriers. Okay. So that's enough for today, but I hope that I both scared you a little and challenged you a little. And actually, as I say, this is the middle of the course, but this is what I do, you know, and all of us do this. And we have questions like this appearing on our exams, and I greatly appreciated your willingness to participate and answer questions. And there was one important lesson that we learned, which is that the teacher makes mistakes. And when you see the teacher making mistakes, you raise your hand and you tell him that he's making a mistake, because he'll appreciate it, or she'll appreciate it, because we all know that we misspeak, and we all know, so that was good. And I'm very glad, you know, because it's easy to not think on your feet all the time. So that's good. Never, if you really think you're right and the instructor is wrong, then ask the question. He will appreciate it, she will appreciate it, regardless of whether he's wrong or right. Okay, so good lesson to learn in life. So any questions from you all? That's those of you who aren't from the South, that's singular. If it's plural, it's all you all, right? So I learned that when I moved here from New York. So any questions about anything? I mean, biology department, bio major, NDV major.
When you're teaching Bio 1 and like first year biology, would you get further into different, like a third more working in with genetics, or would you have to take an upper level genetics class for that, like eye traits or hair traits?
Well, what we do in the first semester is we do simple Mendelian genetics up to tracing 2 genes simultaneously. And then in the second semester, there's a lot of work on gene expression and the actual structure of the genome. So our sequence is very heavily biased towards cell and molecular biology. If you want advanced genetics, right, many of the bio majors take as an elective course a course called human genetics. And that's at the 300 level, but you know, advanced students are taking it in their sophomore year, and other students in their junior year. Then we have a course on epigenetics, which is also very popular, and that's mainly seniors who take that, and it's an extremely good course.
How many biology and immunology classes do you really offer?
All right, we have no courses on virology, and we have no courses on immunology. There is some immunology in the intro sequence, but we currently do not have a course on immunology. But we hope to soon. We've had one for the last 8 years, but the person who taught it is leaving. What?
Is that why it's still in the course hours?
Yep, it is. Because the person who taught it for the last several years is leaving. It's an immunology course. It's on the books, but won't be taught this year. Probably not next year, but the following year will be taught. So when you're a junior and ready to take it, it'll be there. Now, if you really want to do immunology, you can take the graduate course in immunology. A lot of people do take graduate courses. To get an honors thesis, to do honors, you must take a graduate course. So, nope, you don't want to do that.
Sounds so scary.
Yeah. Well, when you're a senior, it doesn't sound so scary.
Yeah, it's easier then.
It's easier then.
Yeah.
But Yeah. So there is a course that is how to describe it. It's not the molecular biology of immunology, but it's the epidemiology of immunology. That course is still offered. So there are two sort of areas. There's the molecular biology, what are antibodies, how are they formed, and on a molecular level, and then more, there's more of a course that is currently taught that's about how do pathogens interact with the immune system to co-evolve. Okay? So that course is still offered to undergraduates. And that's by Antioch. You can look that up. The one by Schlenke is not offered. Next year, the one by Antioch is.
What made you decide to stop teaching NBV and switch to biology?
Well, when you teach a course every year for 20 years, and you teach it both at the undergraduate level and the graduate level, you kind of say, it's time for a change. And although I passionately love neuroscience, and all my research in my lab is on neuroscience, I just wanted to do something different. And so I decided to teach intro bio. And I'll probably do this coming year and maybe another year more, and then I'll probably switch again. But I'm not sure where. It depends on what the department wants me to do. I'm a little bit more flexible than other people in the department because I'm a little older and I don't have any responsibilities at home, so I can change courses without too much trouble to my life. And they move me around in time slots too. You know, sometimes I get 8:30. Next year I'm at 1 o'clock. I never taught at 1 o'clock. I wonder what that's going to be like. From 1 to 2:15. We'll see what that's like. But they move me around. Ronald doing things, what I say.
So what I look at.
Any other questions? So all of you are going to be here as freshmen starting the end of August, right?
Yes.
And this is just sort of a summer warm-up, right? So who of you intend to take intro bio? All right, so 3. And who intend to take intro chemistry? All right. So is everyone likely to be a science major?
Yes.
Pretty much.
They're all intending to be science majors.
Okay.
For right now, at least.
And if you're a neuroscience and behavioral biology major or a biology major, it doesn't matter which one, you're required to take both intro chemistry and